We are going to another tutorial sheet. So the other tutorial sheet we are going to do question 9, which has implicit differentiation, because this one has a lot of questions than the other tutorial sheet we did previously. So on this tutorial sheet, as you can see, we have questions part 1, part 2, part 3, and part 4. These are just the same format. So I only from this I only attempt one question. So let's try it. Maybe I answer part 3. So the way I answer part 3, that's how you answer part 1, part 2, and part 4. So part 3, it has x to the power 5 plus y to the power 5 is equal to 16. So how do you differentiate such equations? So part 3, so we have x power 5 plus y power 5 is equal to 16. So whenever you are told to differentiate this simple function, there's nothing difficult about it. So all you have to do is you differentiate this one the same way. This is just the power law. So differentiation of x to the power 5 is 5x to the power 4. From this power comes here in front of the x, then on the power, since it was 5 minus 1, it will be 4 plus the same thing will work out with y. So differentiation of y to the power 5, it will be 5y to the power 4. Now since for y you have dy dx, which will simply equal to differentiation of 16, it's 0. Then for this one, our main goal is to make dy over dx there subject to the formula. So it will be dy over dx is equal, so it will be 5y to the power 4. Dy over dx is equal to, so this part will come cross the equal sign, to be negative 5x to the power 4. So for us to only remain with dy over dx here, we'll simply multiply by 1 over 5y to the power 4 on both equations, sides of the equation. So even here 1 over 5y to the power 4. So let's cancel out what is common here. So this is common, this is common, you can cancel them out. Then even here you have 5 here, 5 can go, and this 5 can go. So you will simply remain with dy over dx is equal to x power 4 over y power 4. That's how we differentiate this question. So the same will apply for part 1, part 2, and part 3. They are just one and the same thing. So these are very simple things. Implicit functions are very, very simple to differentiate. Then from the same tutorial sheet, let's look at part 5. So on part 5, we have part 5, question. So as you can see, part 5, part 6, as well as part 7, they're just one and the same thing. So even from these 3, let me just answer one of them. So I'm going to answer part 5 or part 6. Yeah. So for part 6, we have x squared y plus y squared x is equal to negative 2. So x squared y plus y squared x is equal to negative 2. So looking at this function now, as you can see, you have x squared. X squared is a function itself, and y is also a function. So we have a product law here which can operate on this first part here, as well as here we can use a product law. So we're answering this one. So we say let's differentiate x. Differentiation of x is 1. So 1, you have 1 here multiplied by, so this is x squared, sorry. So differentiation of x squared is 2x y, then plus, so here we'll maintain the x squared, then we differentiate to the y. Differentiation of y is just dy over dx. Then you are adding here, we'll differentiate the y, it will be 2y dy over, or 2y dy over dx. Then you have this x here. Differentiation of x is 1 multiplied by y squared, it will be y squared is equal to differentiation of -2, it's 0. Then now here, the main goal is to remain with dy over dx as a subject to the formula. So whatever has dy over dx should remain here. Whatever doesn't have should do what? Cross the equal sign. So which functions of dy over dx? We have this here, we also have this here. So it will be x squared dy over dx plus 2y dy over dx. We also have this x here. Then you also have this should be plus y squared. So it's just equal to, so you have y squared here plus y squared is equal to, so y squared, you have a negative here, y squared minus 2xy. So let me, is equal to y squared minus 2xy. Then here, for us to only remain with dy over dx, what will we do? We'll factorize out the dy over dx. So you have dy over dx. What are you going to remain with inside? Here we only have x squared. So it's x squared plus. Here you remain with 2yx. So 2yx is equal to y squared negative y squared minus 2xy. Then you divide over everywhere by x squared plus 2y x. Then here x squared plus 2yx. So our dy over dx will simply be, so it will be negative y squared minus 22xy over x squared plus 2xy. You are done with this function, as simple as that. So that's how the same principle you apply on part 5 and part 7. They are all one and the same thing. In fact, even part 8, that's the same principle that's going to work. Part 9, that's the same principle. So then we go to part 8. Part 8, it's also the same principle, but because it has a root, a lot of you will get confused, say, this one has a root. So let's simplify this one for a root. Let's show it how simple it is. How simple is this function? So on part 8, we have root of x, y. So root of x, y, it's this one. Then is equal to x squared y plus 1. So even this one here, whenever we have a root, just a simple, it's x y to the power half, which is equal to x squared y plus 1. So here you can make x half, y half. So you distribute the power half for you to have everything as easy as possible. Then here you have x squared y plus 1. If you want here, you can work it with like this using the chain rule, or you can distribute through, then you use the product rule. So for this one here now, let's start by differentiating the first part here. So differentiation of x to the power half, which will be half x. So 1 over 2 minus 1, we are going to have, so minus 1 here. Okay, let's do it here so you can, x 1 over 2 minus 1. So this 2 will come here, it will be negative here, so you have negative 1 over 2. Then y 1 over 2 will still remain plus. This time x to the power half will maintain it, will differentiate y to the power half. So differentiation of y to the power half is simply 1 over 2 y to the power negative half dy over dx, which is now equal to, when you go to this side here, we are going to first differentiate the first part, which is x squared. So differentiation of x squared, you see, 2xy. Then plus, we will now go to differentiating on y. Differentiation of y, so we have differentiation of y is just 1. So we have x squared dy over dx plus 1. Differentiation of 1 will give us now a 0. So we are also differentiating it. So we have a plus 0 here. Then now, our main goal is whatever has dy over dx should be on one side. Then whatever does not have should be on the other side. So we have dy over dx here. We also have dy over dx here. So these two can come together. So it will be half y negative 1 over 2 dy over dx minus, when this crosses the equal side, it will be negative, so it will be x squared dy over dx is equal to, so this will still maintain it to be 2xy. This part here will cross the equal side, it will be negative 1 over 2 x to the power negative half, then y to the power half. Then so I've left out this. So this one, this part here, this is all together. So in front here we have x to the power half. Then now, for us to only remain with dy over dx, we'll do what? We'll do the factorization. So it will be dy over dx is open bracket. So here we'll remain with x power half multiplied by 1 over 2 y power negative half, which is equal to 2xy minus 1 over 2x to the power negative half y power half. Then now, for us to get rid of, to only remain with dy over dx, we'll get rid of this by multiplying it throughout. So when you multiply it throughout, this will go away. So we'll only remain with dy over dx is equal to 2xy minus 1 over 2 x to the power negative half y to the power half over x to the power 1 over 2 multiplied by 1 over 2 y to the power negative half. So now let's simplify things. Power negative half, you don't need this. So now let's make it more simple. For us to make it more simple, it will be dy over dx is equal to, so 2xy will still remain minus, so here we have 1 over 2 x to the power negative inverse. So for this one here, for us to bring it back, we are going to bring back the root. So we have a negative power. For a negative, we will introduce what's an inverse. So it will be simply 1 will still remain here over, for this one, so it's 1 over 2. For this one, for it to be bring back the, for to get rid of this negative, it will be root of, since 1 over 2 is root, so it will be root of x here. So it will be 1 over 2 root of x here. Then we have y over 2 over. Then for this one again, what we will do is we have x inverse here multiplied by 1 over 2 y. So x 1 over 2 here will be root of x simply, then multiplied by, so this will be 1 over the same thing we did here, 2 root of y. For you not to remain further, so yeah, for this one here we also have root of y. For you not to remain further confused, you can just leave it from here. So we can just leave it here. But so now let's do question 9 of the third sheet. So we'll do part 11. So in part 11 we have sin x plus 2 cos 2y. Even here things are very easy. What we are going to do is only we differentiate this one plus the differentiation of this one is equal to the differentiation of 1. So we have sine x plus 2 cos 2y is equal to 1. So let's simplify things as quickly as possible. So what's the differentiation of sine x? Sine x is cos x plus. So for cosine functions, we first differentiate this part here. Differentiation of 2y is only it's 2 dy over dx. So 2 dy over dx will multiply with this part, which will be 4 dy over dx multiplied by differentiation now of the entire function, which is cos 2y. It will be negative sine 2y is equal to 0. So this negative times this will be negative 4 dy over dx sine 2y is equal to negative cos x. So here our main goal is only to remain with what? Dy over dx. So whatever doesn't, so this these two will what? Come this side, so we divide by this. So we divide by negative 4 sine 2y, even this side is negative 4 sine 2y, so that this and this can cancel, this and this can cancel. Sine 2y and sine 2y can do what? Can cancel. So we have dy over dx is simply equal to, so negative and negative here will be, they'll do what? They'll cancel each other out. So when you have cos x over 4 sine 2y, as simple as that. So for this one, we want to first start, we differentiate sine x, which gave us cos x. We also differentiated 2 cos 2y. First, we started with differentiation of 2y. Differentiation of 2y, it gave us 2 dy over dx. We multiplied by this 2, it was 4 dy over dx. Then open bracket, we had cos 2y, differentiation of cos 2y is negative sine 2y. So we are only differentiating this cos here. For the differentiation of cos, it's negative sine 2y is equal to 0. Then now our goal was to make dy over dx the subject to the formula. So whatever has dy over dx was to remain this side. Then whatever does not have dy over dx should do what? Cross the equal sign. So this cross the equal sign, that gave us negative cos x, because here it